Alright, today we're going to climb a ladder, a data ladder. We're going to break down the 4 fundamental levels of measurement that you see in statistics. Now this stuff is super important because it tells you exactly what you can, and maybe more importantly, what you absolutely can't do with your data. So let's get climbing. So let me ask you something that sounds really simple. What is the average hair color? I mean, seriously, think about it for a second. What's brown plus blonde divided by 2? Is that even a thing? And the answer is, it's a totally meaningless question, right? You can't perform mathematics on categories like hair color. And that little brain teaser is exactly why we're here today. You've got to match the right kind of math with the right kind of data. Okay, so before we actually start climbing this data ladder, we need to talk about the foundation. All data, I mean all of it, falls into 1 or 2 big families. And those 2 big families are categorical and numerical. So categorical data, that's all about qualities or labels. Think about things like gender, what kind of coffee you prefer, and your favorite brand. You're basically just sorting things into buckets. Numerical data, well, it's exactly what it sounds like. It's a number from the get-go. Your age, your height, your weight, these are all measured with numbers right from the start. Alright, foundation is set. So let's start climbing. You're going to begin with the 2 types of data in that first family, the categorical one. This is where we start just naming things and maybe even ranking them. So the very first rung on our ladder, the most basic level you can get is called nominal data. And hey, the clue is right there in the name. Nominal sounds a lot like name, right? That's because this data is purely about labels. Now, the most important thing to get about nominal data is that the order just doesn't matter at all. Things like hair color, blood type, even the brand of your fridge, it's all nominal. Sure, we could assign a number, say 1 is for brown hair and 2 is for blonde, but those numbers, they're just stand-ins. They're basically just labels with no real mathematical juice behind them. Yeah, this says it perfectly. One color is not ranked above another. There's no hierarchy here. Red isn't better or more than blue. They're just different names for different things. And that's it. That's nominal data in a nutshell. Okay, time to step up to the next rung on the ladder. This is where we get to ordinal data. Now this takes everything we just learned about nominal data and adds one simple but really powerful new trick. And what's that new feature? It's a meaningful order. We still have categories just like before, but now they actually have a logical sequence. There is a rank to them. The classic example here is a race podium, right? First, second, and third place. We know the order, which is great, but this is the big but. We have no idea what the distance is between those ranks. The winner could have beaten second place by a tiny fraction of a second, while the person in the third was like a whole minute behind. See, ordinal data tells you who is in what order, but it doesn't tell you by how much. Alright, we're halfway up. We're leaving the world of pure categories behind and stepping into the numerical levels. This is where we can finally start to actually measure the distance between our data points. And this slide just nails the jump we're about to make. Look at the left with the race results. 2 gaps between first, second, and third. Who knows? They could be anything. But look at the right with temperature. The gap between 30 and 60 degrees is the exact same as the gap between 60 and 90. That constancy is key. And it brings us to our third level. Say hello to interval data. So with interval data, two things are true. The order totally matters, and the differences, the gaps between the values, are equal and measurable. But there's a catch, and it's a big one. The 0 point is totally arbitrary. Temperature, like in Celsius or Fahrenheit, is the perfect example here. Think about it. The jump from 10 to 20 degrees is the same 10-degree jump as from 70 to 80. The intervals are equal. But what does 0 degree actually mean? It doesn't mean there's no temperature, right? It's just a point we all agree on for a scale. And that's why you can add and subtract with interval data, but you can't multiply or divide it. You just can't say that 60 degrees is twice as hot as 30 degrees. The math literally falls apart because the 0 isn't real. Okay, to really make this click, just think about this for a second. What's the real difference between it being 0 degrees Fahrenheit outside and having $0 in your bank account? In that question right there, it leads us straight to the very top of the ladder. This is the most powerful level of measurement, ratio data. It has everything interval data has, the order, the equal gap, but it adds one absolutely game-changing feature, a true, meaningful 0. So what's a true 0? It means the complete and total absence of the thing you're measuring. $0 means you have absolutely no money. 0 weight means something literally weightless. 0 seconds means no time has passed. It's not just some random point on a scale, it's the real absolute floor. And that true 0 is why ratio data is the king of the castle. It unlocks everything. You can do all the math, add, subtract, multiply, divide. Now you can finally say the 20 minutes is twice as long as 10 minutes, or that a score of 90 on a test is 3 times higher than 30, because you have that 0, that true 0. Those kinds of ratio comparisons are finally totally valid. So there we have it. We've climbed all the way from simple names at the bottom to these super powerful absolute measurements at the top. Now let's take a quick look back from our perch up here and see the whole picture all at once. This table just lays it all out so nicely. Look, we started with nominal, which is only categories, nothing else. Then ordinal steps it up by adding a meaningful order to those categories. From there, we jump to the numbers. Interval gives us that meaningful order and a measurable difference. But remember this, no true 0. And finally, ratio at the top, at the very top, has the whole shebang. Order, measurable differences, and that all-important true 0. Every single step up this ladder just unlocks more powerful ways to analyze your data. So here's what I want you to take with you. The next time you're looking at the chart or messing with a spreadsheet at work, just stop and ask yourself, what level of data am I actually looking at? Is it nominal, ordinal, interval, or ratio? Because now you know the rules. And knowing the level of your data tells you exactly what stories it can and cannot tell.